Atomic spectroscopy based on flame atomization. Okay, atomic spectroscopy is the study of interaction between electromagnetic radiation and the atom. Okay, last time we have learned about the UV visible spectroscopy and IR spectroscopy, in which those instruments use the concept of molecular spectroscopy. So this time we're going to learn about the atomic spectroscopy. Okay, flame atomization is the process in which your sample, which is in solution or in solid, will be converted into atom. Okay, so at the end of this chapter, you must be able to differentiate between AAS, atomic absorption spectroscopy, and AES. Okay, you must know the diagram and the function and also the difference between these two instruments. And of course, you must be able to differentiate what is absorption and what is emission. Okay, the atomic spectroscopy, the species that are examined is in the form of atoms, not molecules, not in the form of ion. So the spectral transition yang occur adalah between electronic energy level, electronic transition dalam range visible, UV and X-ray region. Okay, the wavelength of the observed absorption or emission line are characteristic of particular element. So maksudnya different element will absorb the radiation at different wavelength. The intensity of the spectral line is proportional to the number of atoms. Maksudnya the intensity tu maksudnya the intensity of your line or your peak in the absorption spectrum. If the peak is high, then there is high number of atoms inside your sample lah. Now we're gonna differentiate the absorption and emission process. Okay, this one is your electron. Okay, your electron at the ground state. When incoming photon is absorbed by the atom, the electron here will move to higher energy level lah, higher energy state. Then the absorption occur. And then bila this electron dia nak move back to its original or its ground state, dia akan emit the photon and the emission process occur. Okay, so the photon, the amount of photon or the amount of energy yang diabsorb untuk cause the excitation is the same with the energy emitted bila dia nak turun balik ke ground state. Okay, so you mesti tanyakan daripada ground state ni dia langkau satu orbital dan terus pergi ke orbital yang ketiga ni kan. Boleh tak kalau dia ke satu state macam ni daripada sini ke sini? Okay, pun boleh jugalah. Okay, daripada sini dia nak bila dia absorb more radiation, then dia move to higher energy level pun boleh juga. And then bila dia nak turun daripada higher energy level ni, excited state to the lower energy level, dia akan emit the photon in which the emission process take place. So make sure you notice that the incoming photon here adalah sama dengan the photon emitted sebab dia sama energy level lah. Dia sama energy level. Okay, so the amount of photon absorbed by the electron to become excited from here to here is the same. Bila dia nak turn back to its lower energy level, dia akan emit photon. Photon tu adalah photon ni dengan photon ni adalah sama. While photon ni dan photon ni adalah sama. Okay, for atomic spectra, Each element has a characteristic spectrum. For example, sodium gives a characteristic line at 589 nanometer. So atomic spectra features sharp band, okay, sharp band like this. But for molecular spectrum, the band is broader like this. Kenapa? Sebab in molecules, the transition yang boleh berlaku adalah electronic transition, vibrational transition and rotational transition. Why? Because molecule is connected by the bonds lah. Bonds tu menyebabkan dia boleh vibrate and dia boleh rotate. So bila berlaku this all transition, this makes the absorption band for molecular species or molecular spectra, dia akan broad lah. While for atomic absorption band, the transition that occur is only electronic transition. So that's why dia ada sharp band lah. Okay. Okay, macam mana nak tahu sharp ke broad? You boleh tengok dengan mata kasar. And satu lagi, by measuring the bandwidth. Okay, bandwidth ni adalah the width here at half maximum. Okay, so the bandwidth here for molecular absorption band is 25 nanometer, while for atomic absorption band is 0.03 nanometer. Okay, so you boleh tengok kat sini, the molecular absorption band, how the electronic, vibrational and rotational energy level contribute to the broad band here. Okay, for application of atomic spectroscopy, okay, it is widely used in industry and research due to its high sensitivity for qualitative and quantitative determination of metallic element. Okay, dia boleh tahu, qualitative dia boleh tahu the presence of that metal, ada ke tak, and also dia boleh determine the concentration of the metal inside the sample lah. Quantitative determine concentration. Nanti kita akan belajar, kita akan lukis graph, apa semua tu kan. Okay, the first one is for the clinical study. Let's say you want to determine the presence and the concentration of calcium or magnesium in urine. And then for environmental pollutants, okay, you will ambil sample daripada water sample from different river, dan you boleh test the amount, the concentration of this metal inside the river, let's say, in order to know the amount of pollution happen in that particular river lah. Okay, then for forensic study, let's say you want to determine the presence or the concentration of the let's say metal in the hair, in your hair. So macam forensik lah, you boleh tahu kalau dekat rambut orang tu ada lead ke, ada copper ke, you boleh tahu dia sebelum kejadian tu dia pergi kat mana ke, something like that lah, untuk forensic study. So for toxicological study, okay, you nak tahu the toxicity of that, contohnya plant lah. Plant, you have found plant, tumbuhan yang boleh cure certain disease or boleh as antioxidant, for example. You dah proven its efficiency lah. So sekarang you nak tahu dalam plant tu ada tak heavy metal. Contohnya chromium, mercury ke apa semua kan. So you nak tahu, you boleh guna juga AAS. Okay. Kemungkinan dalam plant tu ada juga heavy metal due to the due dia absorb melalui soil ke apa semua. Okay. So this AAS is very useful to determine the metal inside your sample lah. Okay. Okay, elements detectable by atomic absorption. Yang warna, okay, yang warna purple ni yang boleh kita determine, elemen yang boleh kita determine melalui AAS, atomic absorption. Okay, there are 3 technique dalam atomic spectroscopy, which is AAS, AES dan juga atomic fluorescence. But in this study, we'll focus on 1 and 2 only. Okay, AAS, principle Okay, AAS is based on the same principle as the flame test used in qualitative analysis. Okay, bila alkali metal or salt or alkali metal salt or calcium, strontium or barium salt is heated strongly in a Bunsen flame, a characteristic flame color is observed. Okay, for example, untuk bila ada sodium, the flame color will be yellow. Lithium crimson, calcium brick red, strontium crimson juga, barium, the green flame will be observed. Okay, kenapa? Why? Okay, kenapa? Kenapa dia observe color? Sebab the high temperature of the flame will excite a valence electrons to a higher energy level. Okay, high temperature of flame juga boleh menyebabkan electron to become excited and move to higher energy orbital. Okay, kemudian the atom then emits energy in the form of visible light as the electron falls back into the lower energy orbital. So maksudnya atom tu due to the high temperature of the flame dia akan excited dan emit the visible light. So that's why light yang ada atom ni will be ada color. Okay, kenapa kena ada flame tu? Kenapa konsep flame is used? Sebabnya flame tu atomization process akan berlaku dalam flame in which the ions in our sample are reduced to gaseous metal. So maksudnya dalam sampel kita tu contohnya dah ada in the form of solution. So bila kita heat dalam flame, dia akan jadi dalam bentuk atom, dia akan converted to atom. So sebabnya dia adalah atomic spectroscopy. Kita nak check the interaction between the atom, bukannya the compound. So that's why in the flame your sample will be converted to atom. Okay, contohnya ni adalah flame. Okay, flame. Okay. Okay, flame dia akan berlaku yang menyebabkan warna untuk flame ni dia akan berlaku excitation of your atom due to the high temperature of this flame lah. So bila dia excited dia akan go back to its ground state lah, akan jadi atom balik. So at that time lah the radiation from the source, okay, the radiation from the source akan go towards this flame, then this ground state atom will absorb the radiation from this source. Okay, so the ground state atom absorb light of the same characteristic wavelength as it emit when returning from the excited state to the ground state. So the intensity of the absorbed light is proportional to the concentration of the element. Ini macam biasalah, the amount yang dia boleh absorbed from the source bergantung kepada the amount of the element, the concentration of the element present in this flame or in your sample lah. Okay, so absorption or emission of atomic vapor is measured. Okay, kalau okay, ni your source, dia akan emit radiation and then your sample inside the flame will absorb this radiation and akan didetect oleh detector. Ni untuk absorption. Okay, so kalau untuk emission spectroscopy tak ada source ni. Source ni tak ada. So maksudnya dia hanya bergantung kepada flame ni lah. Hanya bergantung kepada flame. Bila dalam flame ni juga dia boleh your sample boleh become excited and move to higher energy state. Lepas tu bila dia nak move to lower energy state, dia akan emit radiation. Then the emitted radiation ni terus pergi detector untuk AES. AES. Kalau untuk AAS, dia kena ada source of light. Okay, yang ni kita akan pergi detail. So, ni just brief lah. Okay. Untuk atomization process or sample introduction. So, this dalam atomic spectroscopy, analyte must first, atoms of the analyte must first be formed, usually in the form of an atomic vapor. So atomization is a process by a sample is converted to atomic vapor. Macam mana? Okay, macam mana nak atomize tu? The solution of the analyte is evaporated rapidly at an elevated temperature to yield a finely divided solid. So device yang kita guna untuk convert sample to atomic vapor is atomizer. Okay, so dalam this case, your atomizer kita guna flame, in which the typical atomization temperature is from 1700 to 3150. Okay, in the flame atomization, there are three processes: nebulization, dissolution, and volatilization. Okay, untuk nebulization ni, dia convert your liquid sample to a fine spray ataupun fine aerosol. Okay, masa ni dia convert to fine spray. Okay, fine spray ni dia dalam bentuk macam spray lah, droplet. Maksudnya solvent you ada lagi. And then lepas nebulization, your sample akan pergi ke flame. And dekat flame tu akan berlaku dissolution, which is in which your sample your solvent akan being evaporated and form dry aerosol. Then lagi dalam flame ni juga akan berlaku volatilization, in which your dry aerosol are converted to a vapor in the flame. Okay, vapor in the flame ada molecules, free atoms and ion form. Okay, senang cerita macam ni. Okay, this is your solution sample. Dia akan berlaku nebulization process and your sample akan jadi dalam bentuk fine spray macam ni. So dalam masa ni ada lagi solvent. So bila your sample move and go to the flame, dia akan berlaku dissolution, which is the removal of your solvent by evaporation due to the flame. Dan akan terbentuklah dry aerosol. And then dalam flame ni juga, sample dry aerosol ni akan being volatilized and occur in this three state, whether free atoms, molecules or ions. So yang kita nak guna untuk atomic AAS ni adalah these free atoms. Okay, the properties of flame. Okay, flame ni akan terbentuk bila ada mixture of fuel and oxidant. So ni adalah combination antara fuel dan oxidant, dan dia akan membentuk temperature yang dia akan jadi temperature yang berbeza bergantung kepada combination ni jugalah. Okay, selection of flame type depends on the volatilization temperature of the atom of interest. Most common is acetylene. So kita tengoklah sampel kita tu akan volatile pada temperature mana. So kita boleh pilih this combination of fuel and oxidant ni lah. Okay, now we move to the flame structure. There are three zones in the flame. Okay, the first one is primary combustion zone. Is characterized by existence of some non-atomous species and the presence of few species that emit in the blue region of the electromagnetic. Okay, so dekat primary combustion zone ni, dia ada non-atomous species dan juga dia ada gas combustion product yang akan emit radiation. Okay, dan zone kedua adalah interzonal region dekat tengah ni, and it is the hottest part of the flame and best for atomic absorption. Kenapa? Sebab dekat interzonal region ni dia rich in free atom, so that's why it provide the best location for measuring atomic absorption. Okay, then the secondary combustion zone dekat luar ni, atom akan form molecular oxide and are dispersed into the surrounding. Atom tu boleh form molecular oxide dengan oksigen dalam flame ni and form molecular oxide lah. Okay, so this is the temperature profile. Okay, the temperature profile macam korang tengok tadi, yang kat tengah tu adalah yang paling hottest zone lah. Okay, ni temperature dia lah. Okay. Okay, now nebulizer. Okay, the nebulizer macam mana dia boleh the aspiration process akan berlaku dalam nebulizer. Okay, ni structure gambar nebulizer ni. Okay, the aspiration is the uptake or suck of the liquid sample up to tube and into the nebulizer chamber. So, dalam nebulization process in nebulizer akan create a fine aerosol ataupun fine spray for introduction into the flame. So, apa yang berlaku dalam nebulizer aspiration process akan berlaku in order to create a fine aerosol. And also dalam nebulizer, dia akan mix aerosol, fuel and oxidant thoroughly, which creates a heterogeneous mixture. The smaller the size of the droplets produced, the higher the element sensitivity. Okay, there are 4 types of the nebulizer. Okay, depends lah macam mana, tapi konsep dia akan produce a fine spray. Okay, so you boleh tengok. Okay, methods of sample introduction in AAS. Okay, there are a few methods which depends on type of the sample. Okay, so kalau solution auxiliary kita guna nebulizer ni. Kalau untuk solid kita guna 2 ni, 4 ni. Macam tu lah, depends on types of your sample. Okay, burners. Okay, burners ni dia consists of inlet tube, fuel and air inlet, nebulizer, mixing cell and the flame. Okay, so burner ni will act as the atomizer in order to convert the sample into gas phase atom or elementary ion. Okay, the burner head is where all the chemical reaction take place. Burner head ni tempat yang keluar flame tu lah. Okay, there are 2 types of burners in flame spectroscopy. Okay, which are the turbulent flow, which is total consumption burner. And the second one is laminar flow, which is also called as premix burner. Okay, now we look at the turbulent flow burner. Okay, in this burner, the nebulizer and burner are combined into a single unit. Sample is drawn up the capillary and nebulized. Okay, so kat sini from your sample solution, dia akan go through the small capillary tube and was introduced to the flame in a fine spray, and at the same time the oxidant and the fuel juga akan go to the flame lah. So dia akan sample oxidant and fuel akan pergi serentak. So sebab tu dia kata nebulizer ni nebulizer untuk form fine spray dengan burner ni are combined into a single unit. So the resulting flame is turbulent and non-homogeneous. Okay, nanti saya akan bagi YouTube and you boleh tengoklah kalau turbulent flow burner ni macam mana dia tak homogeneous. Okay, flame dalam turbulent flow ni dia tak homogeneous. So it is not very useful to be used dalam atomic spectroscopy. Kenapa? Sebab so the width of the flame tu akan jadi tak sama, and ini sama juga efek macam cuvette lah. Okay, cuvette sample holder tu dia kena same wavelength kan. Kalau tak akan jadi mismatch cell. Ni konsep ni juga berlaku kalau flame tu tak sama width lah. Dia tak homogeneous. Okay, so the advantage for this turbulent flow is dia boleh introduce relatively large and representative sample into the flame. Dia boleh introduce a large sample lah ke dalam flame tu. Okay, the disadvantage dia ada relatively short path length. Dia akan menyebabkan clogging of the tip, and also can cause noise lah. Okay, the second type of burner that is usually used is laminar flow burner. Okay, sample is nebulized by the flow of oxidant which flow through a capillary tip. Okay, sample tu dia akan lalu ikut capillary tip and being nebulized dalam form fine spray lah. Lepas tu, the fine aerosol or fine spray is then mixed with the fuel and flow through a series of baffles. So, dia akan ada satu chamber which make the fine aerosol, fuel and oxidant, and dia akan go through a baffle. Only finest droplet went through the baffle. Bigger sample droplet is collected at the bottom of the mixing chamber, then drained to a waste container. So sepanjang dia lalu ikut baffle tu, bigger sample akan jatuh ke dalam waste container. So maksudnya yang akan um, di yang akan pergi ke flame tu adalah yang betul-betul kecil, yang betul-betul fine lah. Okay, aerosol, oxidant and fuel are burned in a slotted burner that provide a flame of 5 to 10 cm in length. Okay, um, this is the diagram for laminar flow burner lah. Okay, dalam laminar flow ni, the fuel, oxidant and sample all meet at the base of the flame and is pre-mixed prior to entering the flame. Dia orang akan dimixkan, pre-mix, sebab tu nama dia pre-mix burner kan, sebab dia akan di pre-mix kat sini before going to the flame. So the flame yang akan dihasilkan adalah more homogeneous lah. Okay, so advantage for this laminar flow burner, it provide quiet flame, provide longer path length that enhance the sensitivity and reproducibility. Okay, tapi disadvantage dia, the lower rate of sample introduction sebab dia kena go through the baffle tu kan. And then possibility of selective evaporation of mixed solvent in the mixing chamber could create analytical uncertainty. And also, the mixing chamber contains a potentially explosive mixture that can flash back if the flow rates are too low. Sebab dia kumpul dulu dalam mixing chamber dan mungkin akan akan ada explosion lah. Ada potential nak ada explosion. Okay.